Welcome to the VMT tutorial on the ASCII to GIS utility. This is a standalone utility within the VMT toolbox. It's most useful for extracting depth average and time series data from ADCP data for import into GIS type environment. The purpose is to allow ADCP data in ASCII output files to be easily imported into ArcGIS. What it does is creates text files that can be easily imported into a GIS or type in program or other associated program. The most useful type application would be, for example, consider you do a sweep survey or a serpentine route with an ADCP and you'd like to evaluate a distribution of depth or layer average velocity and backscatter through a survey reach. So it's not a transect based survey where VMT would be really useful. It's not longitudinals, but instead it's this serpentine route. With this particular utility, you can go in through the browser window similar to VMT and grab the files that you want, tell it all the files that you want to have included in this GIS export file, and once that's done, it's going to prompt the user for a depth range. Within the interface here, we can tell it we want depth from surface or a height above bottom. For the data extraction, oftentimes perhaps you just want to extract the full depth of flow. If you check this box, it'll give you the depth average or the full measured depth. If you choose depth from surface and this is not selected, it'll either give you or it'll allow you to enter 0 and 1. In this case, this would be between 0 and 1 meters in depth. We've told it the units here for these inputs are in meters. We can also do it in feet. We can enter anything here that's realistic within the water column, or we can choose a height above bottom option and set a limit. So in this case, if I chose height above bottom and this was set to 1, it would give me anything between the bed and 1 meter above bottom. And within this utility, there's also some new plotting routines that allow you just to visualize the data that you've exported. It performs averaging on each ensemble in the set of measurements. No averaging is applied between successive ensembles. This is different compared with something like VMT, which does the transect averaging. This does not average between ensembles. Each one is an independent sample, and it's just doing a depth average over each ensemble. And it creates a single CSV file, and it includes both the depth or layer averaged velocity data as well as ancillary data like heading, pitch, roll, ADCP temperature, and so on, backscatter values. Where this might be useful, as I said, with this serpentine type survey, this example that's shown on the screen is a multi-beam echo sounder survey on the Mississippi River. The black lines are the ship tracks. This was collected over 2 days during a bathymetry survey. We went ahead and ran the ADCP at the same time, and it allowed us to extract the ADCP data over this same domain and visualize the flow velocity that was collected at the same time as the bathymetry. So what's shown on the right here is the multi-beam bathymetry. This is a preliminary version of some of the data that came out of the survey. And what we can do then is use this tool in the GIS environment to extract the data and visualize it with using the GIS tools. And it shows us, in this case on the left, is depth average velocity. This is the magnitude. So we see the flow acceleration along the outer bank or the right bank looking downstream. Flow over some of the dune features here. And deceleration on the lee side of the dune, the response to some of these channel training structures, and so on. We can also visualize things like backscatter. In this case, this is a depth average acoustic backscatter as reported by the Wind River software, and we see that we have higher backscatter values as the flow accelerates on the outside of the bend. So we're in training more sediment up into the water column, and mobilizing the sediment at the same time. So this is an example of what you can do with ASCII to GIS, and now we'll move into a quick demonstration. Okay, so to run the ASCII to GIS utility within the MATLAB environment, at the command prompt, type ASCII to GIS with an underscore GUI, GUI. If you're going to run the ASCII to GIS outside of the MATLAB with the executable, just run that ASCII to GIS executable. And we type enter, and we see we get the ASCII to GIS utility window that we just discussed coming up. So in this case, I'm going to just do a full depth average. This is going to be a average over the full measured depth, so it's not going to include side lobe interference, that is data loss to side lobe interference or ringing near the surface. So I'm just going to leave it as full depth average over the full water column and for a measured water column, and I'm going to say run. And I'm going to find my data files. So we're going to do the White Wabash confluence. And now that I've selected that directory that contains the ASCII output files, I say OK. I want to select all four. A lot of these dialogues you'll notice are the same as VMT. And I say OK. And now it's going to tell me it's loading our data files. Depending on the speed of your computer, this can be fast or slow. So be patient. Once things are finished, it'll say conversion complete. So we say OK. And now we have data files within our process files directory, the single file that has the GIS output. So let's go ahead and move to our GIS directory. And we see here within the White Wabash data where we have our ASCII files, we see this White Wabash ASCII GIS file. And it's a CSV file, so I'm going to go ahead and double click it. It'll open up in Excel for me just to show you what it looks like. And I'll make it so you can see all the columns here. So what we have is just a basic table of data with ensemble. There's a timestamp, our latitude and longitude, heading, pitch, roll, temperature, and the average depth from the four beams as reported by the ADCP. We have individual beam depths. These are still only just referenced to a single location, so they're not terribly helpful. Backscatter value, and again, this is a depth average backscatter, depth average velocity in the east direction, in the north direction, velocity magnitude, direction, vertical velocity, again, all depth averages. And then coming soon, we'll have, by fitting the profiles, the velocity profiles, we can get an estimate of shear velocity and the roughness length. And we're still working on those subroutines for that. So anyway, this is what the basic data file looks like. Everything's been formatted for easy import into GIS. So let's go ahead and do that. So we will open up our GIS. And I've already preloaded here the imagery for the White Wabash confluence. So I can go up here to Tools, Add XY Data, and I can browse for that file. Oops, wrong one. And so again, that was the ASCII GIS CSV file. I say add, and it's chosen the wrong Y field, so I just correct that. And that's going to be our latitude, and we want to give it a coordinate system. This data was collected. Its geographic coordinate system, we're giving it a latitude, longitude, and we're giving it in WGS 84, which is what our data was collected in. So I say OK. And it gives me a few warnings, and there's our data in the GIS environment. And we can see if we go to our attribute table, we've got that same data set that we just looked at, all in our GIS environment. So we can do with it what we please. So that's one quick way to get the ADCP data into the GIS type environment. If we wanted to use, I mentioned that one of the things you're getting in this attribute table are the individual beam depths. So we've got the individual beam depths, beams 1 through 4, but they're all georeferenced to only the ADCP position. Within the VMT utility, in the main VMT program, you have the ability to export multi-beam data, so you get individual georeference beam depths. And I've already done that in this case, and so I can turn those on here. They come into the GIS environment in a very similar manner, and it allows me to get individual beam depths for each of the ADCP beams. They're corrected for heading, pitch, and roll, and georeference based on the ADCP position. It's basically just geometry. And so each one of these is the white dots is an individual beam depth, and you can see here's our ADCP as it was moving through collecting the data, and this is where each of the beams was hitting the bed. So we're getting, in this case, 4 individual soundings, depth soundings for each ensemble. And so that gives you an idea of what the multi-beam XYZ CSV data file looks like. And again, that one is a similar attribute table. In this case, it's in UTM coordinates. It gives you the bed elevation, timestamp, heading, pitch, roll, and so on. And again, to get this multi-beam CSV file, it's not a part of this ASCII2GIS utility, but it works in a very similar manner, and it's run through the main VMT GUI window. So that's a basic overview of the ASCII2GIS utility within VMT. And if you have more questions, you can see myself, Ryan Jackson, with the USGS, or talk with Dan Parsons of University of Leeds, or read our user guide for VMT for more information. Thank you. Just as an update to the ASCII2GIS utility tutorial, I wanted to give you a brief overview of a new addition to this utility is this plotting routine. Basically, it allows you to plot the data that you've exported. So once you've chosen your parameters for exporting the data, whether it's depth from surface or height from bottom and so on, you have the ability and run it. You have the ability to plot that data. So in this case, you give it a vector scale that affects the length of the vector and the vector spacing. So in this case, you want to plot every ensemble if that's set to 1. If you set it to 5, every 5th ensemble will be plotted, and so on. So I'm going to set this to 2 right now. I'm just going to make the vectors 2 units in length. They're arbitrary units, just affect the scale, and I'm going to say plot. And it's going to generate a plot for me. And right now I'm working on a dual monitor, so I'm going to move that over so you can see it here and reorganize things a little bit. And what we see is we've got 4 transects. Each of these transects, every ensemble is being plotted in this case because we've chosen an ensemble spacing of 1. And we've got, again, this is the White Wabash confluence, so the Wabash water coming in here, the White River coming in here. And to make it a little clearer, I can add a background if I choose by going back to the VMT utility and choose the White Wabash aerial photo. And this is something I've prepared ahead of time. I've downloaded this imagery, and it's UTM coordinates for all imagery to be able to plot it. And so we can see that now we've got our data at the White Wabash confluence. We can see the shear layer on the day that this photo was taken is a little different than the day that the data was measured. But we see the shear layer show up nicely. And basically what VMT is doing internally is averaging all these vectors together to give you one single cross-section. This utility allows you to get all the data out along the curvilinear ship tracks and not do the transect averaging. Now, if we choose, we can reset the vector scaling or vector spacing. That is, say I want to show every fifth transect because there's just too many. I can change that and replot, and it shows me every fifth vector, every fifth ensemble. I can again add our background file, and we're back to where we were before. With just fewer vectors this time. So this is a nice feature, a nice utility. You can export these figures by choosing File, Export Setup, or Save As. There's two options for saving this imagery, but it's just a nice way to allow you to access all the data without transect averaging along the curvilinear ship tracks and so on. And again, this is depth average in this case over the full depth. If I chose, I can do a layer average between two depths, or I can do an average height above bottom and set a limit between the bottom and say 2 meters or 1 meter above bottom and so on. Anyway, that's an update to the ASCII2GIS utility. Again, if you have questions, you can talk to myself, Ryan Jackson, with the USGS, or Dan Parsons with the University of Leeds. Thanks.